Today we're going to discuss about 20ME601 metrology and measurements. So already we discussed first unit basics of metrology. So now we're going to discuss unit 2 linear and angular measurements. So for this unit we're going to discuss about the linear and angular measurements. So linear measurements like vernier caliper, vernier height gauge and depth gauge, and micrometer and depth micrometer, slip gauge and limit gauges and its classifications, and comparator, mechanical comparator and electrical comparator and pneumatic comparator. And angular measurement is sine bar, bevel protector and autocollimator, angle decker. So these kind of instruments for this unit we going to discuss. The first one is dimensional measurements. So dimensional measurements is common measurement is dimension of an object. The types of measuring instruments. The first one is low resolution device. This resolution is up to 0.25 mm. For example, the first one is steel rule and steel rule with assistance of calipers, dividers and surface gauges, and third one is thickness gauges. These are all the low resolution devices, and second one medium resolution devices. These measurement instruments, the resolution is up to 0.020025 mm. So these medium resolution devices like micrometer with assistant of telescopic and extensible ball gauges, and vernier and dial indicators and measuring microscopes. And third one, high resolution devices is that means less than microns. It's like cage block and comparator. These are all the high resolution devices, and the include the measurements of length, diameter, height and thickness. These are all the linear measuring elements, and these things are going to measured by the vernier caliper and micrometer and slip gauge and limit gauge and comparator. So briefly we going to see about the vernier caliper. So the vernier caliper, it's a measurement, linear measurement. It will be measured the internal and external diameters and length of the shaft. These things are we going to use the to measure the vernier caliper. So vernier caliper is construction by the L-shaped frame with movable jaws and the vernier scales, and L-shaped main scale and vernier scale. Vernier scale have the two locking nuts and movable jaws to fix the or to hold the workpiece to be measured. So next, the main scale, that means the vernier caliper least count is 0.02 mm. So how to measure the least count of the measuring element means, so first we going to measure the main scale readings, which one small divisions on main scale is 1 mm and number of divisions on vernier scale is 50 mm. So 50 vernier scale divisions is equal to 49 on main scale reading. So we go to calculate least count is equal to 1 main scale division is minus 1 vernier scale division. That means 1 by 50 mm. So final answer, the least count of vernier is 0.02 mm. And types of vernier caliper. So here the type A vernier caliper as shown in figure. So type A, we have the internal diameters and external diameters also to be measured for this type A vernier caliper. So next, the type B calipers we have only measured in the length of the object and outside diameter of the object. These things only measured by the type B vernier caliper, and type C vernier caliper, it will be measured length of the shaft and also the internal and internal diameter of the shaft also to be measured by using the type C vernier caliper. So next, the errors in measurement with vernier caliper. So what are all the errors occurring at the measurement in vernier caliper? The first error is errors may arise in manipulation of vernier caliper, and jaw movement should be perpendicular to scale reading, and contact portion of measuring jaws should be good condition. So these things are errors to be made in the by using vernier calipers, and care and precautions in use of vernier calipers. The first one is the jaws should not be used as a hammer because vernier caliper is not a strong instrument. The instrument should be kept in box and not suddenly dropped and turned up and down. And next to care, that should not be used with oil or grit and chips in the pot to be measured. And next one hand of operator should be used for stationary jaws and the other hand supporting the movable jaws while measuring, and the operator should wear eyeglass and magnifying glass during the measurement because the accuracy of measurements mainly depends on the sensing of sight and sense of touch. So these are all the care and precautions of vernier caliper. So next we go for the vernier height gauge. The vernier height gauge to use to find the measurement of the height of the object. So here we have the base, and also the base is along with fixed in the main scale, and the main scale is attached by the vernier scale by using two locking nuts. So here the vernier scale is attached with the measuring jaws. So these measuring jaws to find or touch the object of the height of the object. So next, vernier depth gauge. So vernier depth gauge is also, it's one of the linear measurement to measure the depth of the hole of the object. So the vernier depth gauge figure also we going to see in the figure. Here, the vernier scale is fixed with measuring jaws, and they find the adjustment screws or locking screws by using the by fixing the main scale. So next, the errors in measurement in depth gauge. So here the depth gauge we have the main scale or depth scale is fixed by flat surface, and base is lifted when the measured point is side with pressure, or and third error is point pressure causes the base a drive, and master dial indicator vernier caliper. So these are also one of the linear measurement by using dial gauge. So internal and external diameters to be measured by using the dial indicators. And next one, the combination of depth and angle gauge looks like protector. So this is also one of the linear measurements used to measure both angle and depth of the object. And digital length gauges indicated in digital display while measuring before measuring is set to 0.